Identify the balanced dissociation equation in the given values. We are given the equilibrium equation for the ionization of nitrous acid, HNO2. In water, HNO2 is in equilibrium with H to the power plus number 2 to the power negative quad K. A equals 4.0 times 10 to the power minus 4. The initial concentration of nitrous acid is HNO2. Initial equals 1.0 molar. Set up the acid dissociation constant, Ka, expression. The equilibrium expression for this weak acid ionization is Ka equals H to the power plus number 2 to the power negative over HNO2. Define equilibrium concentrations using an IC table approach. Let X represent the concentration of HNO2 that ionizes to reach equilibrium. H to the power plus. Equilibrium equals X. Number 2 to the power negative. Equilibrium equals X. HNO2. Equilibrium equals 1.0. X. Substitute the equilibrium values into the Ka expression. 4.0 times 10 to the power minus 4 equals X to the power 2 over 1.0. X. Apply the weak acid approximation. Since the equilibrium constant is small, Ka equals 4.0 times 10 to the power minus 4 LL1. We can assume that the amount of acid that ionizes, X, is negligible compared to the initial concentration of 1.0 molar, 1.0, X approximately. 1.04.0 times 10 to the power minus 4 approximately X to the power 2 over 1.0. Solve for X, which equals the equilibrium, H to the power plus. Concentration X to the power 2 approximately 4.0 times 10 to the power minus 4x equals square root of 4.0 times 10 to the power minus 4 equals math 2.0 times 10 to the power minus 2 molar quad, or 0.020 molar. Note, because 0.020 molar is only 2% of the initial concentration, this approximation is highly valid and easily passes the standard 5% rule. Calculate the percent ionization. The percent ionization is the ratio of the concentration of the ionized acid at equilibrium to the initial concentration of the acid, expressed as a percentage. Percent ionization equals H to the power plus equilibrium over HNO2. Initial times 100% ionization equals 0.020 molar over 1.0 molar times 100% equals 2.0%. This identifies option D as the correct answer. The correct answer is option D, 2%.